Now we will finally discuss the steel and glass roof covering the courtyard of the Dutch Maritime Museum under which we are standing. And for this discussion, I refer to an expert, my colleague Sigrid Adriaansens. Sigrid, why don't you start by telling us a little bit about the history of this structure?
So this is the Dutch Maritime Museum in Amsterdam. In the late 17th century, it was the headquarters of the admiralship, and then it became a gunpowder house, a prison, and then it became a museum. In the beginning of the 21st century, the museum needed more space and wanted to integrate this courtyard into its circulation space and shelter the courtyard from weather. You see here a plan view of the museum with an open courtyard in the middle.
So I can see how adding a roof over this space was a solution.
Indeed, a design competition was held for a new glass roof that added value to the historic building. In 2005, Ney & Partners, a Brussels-based engineering design consultancy, won this competition with a steel and glass shell design, and I was part of the competition design team.
Now I know from previous discussions with you that the form of this roof has strong symbolic meaning. Can you tell us about that?
Yeah, this building really represents the Dutch maritime power in the 16th and 17th century. The history of the Dutch as a seafaring nation was closely linked to the production of sea charts and associated sciences such as geometry, topography, and astronomy. We see some of these maps here in the museum. We were particularly interested in this map of the 16th century showing the world as the Dutch knew it at that time. The map also shows a set of windroses. We wanted to use this map in our design to tell a story and connect the courtyard roof, the building's history, and its relationship to the sea. A windrose shows the main wind directions. On this map, we see 17 windrose centers from which the Dutch thought the winds originated. Each center of a windrose is connected with a straight line to the centers of the other windroses. This results in an interesting geometric pattern, which you can see here. We wanted to use this pattern as the grid for our steel grid shell design. So, we connected the centers of 4 windroses, which gave us a square plan. We then imagined how we could use this square plan geometry as the basis for our courtyard roof. You see here this geometry imposed on the courtyard of the museum in plan.
But Sigrid, a grid of flat beams cannot possibly span this large courtyard. You had to give it some lift. So how did you find that vaulted form?
We used a computational form-finding technique based on the hanging cloth model to find the grid shell's vaulted shape. What you see here at the top of this image is the initial 2D geometry extracted from the map with windroses. And at the bottom of the image, you see the hanging cloth shape, which, when inverted, gives us the 3-dimensional grid shell vault.
Sigrid, most design projects have challenging design constraints. This one had some as well. Why don't you tell us about those?
First, the new courtyard roof could not appear above the ridges of the existing historic building, and that's why you cannot see the grid shell when you approach the museum today. So the new grid shell roof could not transfer any horizontal loads onto the heavy masonry walls of the existing building because they might topple over. And the third constraint was that the roof had to be cost-effective.
One thing that fascinates me about these vaulted structures is their construction technique. Can you tell us how this was built?
Yeah. The steel grid shell was constructed in subparts off-site and then lifted with cranes onto the site because we are here in a very built-up urban environment. The parts were then assembled on scaffolding and welded together until the whole grid shell was complete. After that, the glass panels were fixed to the grid shell and the scaffold was removed. This is what the grid shell looks like from a bird's perspective. You see here how the boundary conditions have influenced the design. First, the height of the grid shell is lower than the surrounding roof of the historic building. This results in a very shallow vault. Second, the new roof does not transfer any horizontal forces onto the old masonry walls, so they do not topple over. Third, you can also see how all glass panels are flat and the steel members are very thin. All these design characteristics result in a more economic construction cost.
And here we are at the inside of the courtyard, looking up at the grid shell. The grid of steel elements reads like a fine line drawing against the sky.
Can you see the map with the windroses? The grid shell becomes a strong visual form that links the old existing building to its marine history. The grid shell has a very strong symbolic value.
Do you feel that your design was successful?
I feel particularly happy with these structures. People come here to enjoy their lunch, play and do cartwheels, or admire the roof and feel a connection through the abstract pattern to the history of this place. When you lie on your back, the shell might make you think about how the Dutch sailed the seas, especially when the LED lights inserted at the grid shell notes light up at night. You feel like you might be on the sea, under a starry sky, looking at a map.
Let's do a quick comparison now between the Berlin Central Station and the Dutch Maritime Museum. They're both steel and glass vaulted structures, but they're different in many aspects. So for example, from the scientific point of view, the Berlin Central Station used computers and traditional approaches to analysis, whereas the Dutch Maritime Museum used this new technique of numerical form finding that you described. From the social point of view, the Berlin Central Station was a transportation hub. Here we had the practical objective of creating a courtyard over a historic building. From a symbolic point of view, the Berlin Central Station connected the east and the west of Germany. And here we see, inside of the Dutch Maritime Museum, a seafaring nation and sea charts representing symbolically the history. And then finally, if we look at the design constraints, in the Berlin Central Station, we had a complex transportation network, and here you spoke about the height and the loads, both vertical and horizontal. So it's interesting to see how we have two structures that are both designed of steel and glass, both vaulted structures, but very different scientific, social, and symbolic aspects, as well as design constraints.